Hey everybody, Thrift Store Hacker back again, and it's not a cryptocurrency video. We're going back to the roots of the channel here for this one. And as you can see, I have my homemade e-bike battery here, and this is two 7S 4P batteries. So 7 batteries in series and 4 wide, 4 in parallel, which each battery puts out about, with the age of the batteries and stuff, each battery probably has about 8 amp hours at 29.5 volts, which is the top for a 7S battery, like top charge. So, since I have 2 of these, I usually use them one of 2 ways. I either chain them together and run my e-bike that way, or I use 1 pack at a time, and I have a pack to go out, and then when the battery dies, I have a pack to get myself home. Now, another thing I can do when I'm doing short trips is use this to power other things. So I'll move this out of the way, and let me show you what I built. I built this. Okay. I built this. Now, the inverter is a little oversized. I can use a 120 watt inverter, but I had old reliable lying around. The main key to this point here, though, is this little guy. This is a buck buck converter. What this is going to do is it takes the 29.5 volts and brings it down to a voltage that's acceptable to run in this. And this was just a little, I think it was like a $15 Amazon buy. The inverter may be 400 watts, but what's going to limit this whole system is this right here, because this is only good for, oh no, it says like 160 watts, but I don't want to push this much past 100, even though it's got a little heat sink and everything on it. I don't really trust it because it's made of Chinesium. But anyway, let me show you how this works. I was nice enough to make a diagram. So we'll just move this out of the way. As you can see, it's really simple. If I can get the camera to focus. And we'll zoom in a little bit here. So, we have the battery and some horrible glare. Maybe we'll turn this light on over here. Ah, okay, that's a little better. So we have the battery. Coming out of the battery, we have a switch on the positive side. It goes up to a fuse, and then it goes into the buck converter. Coming out of the buck converter, when it converts it down to a voltage that the inverter can handle, the positive and the negative go straight into here. This has its own internal fuse, so I'm not too worried about it. That and this is not going to see enough power to overload. So it's a pretty basic system. So what we can do here is install the e-bike battery, which I had this board right here that was sitting around in this bin that I can't find the lid for, but I'll eventually find the lid for it. And it just made a nice little container to stash everything in. So we'll hook our positive line up here. And our negative line up down here. Put my fancy cover on that. Now, unlike my other batteries that I've built, this one only comes in at about 10 pounds, inverter package and all. So it makes it very portable. And you can run lighting and all that stuff off of it for a really long time if you're using like little compact fluorescent things like that, or my big studio light here, which is the same fixture, but it's got a 100 watt equivalent LED in it. So, let's power this up and I'll show you how it works. Power my switch on, which turns on the buck converter. And we can zoom in on that. See if I can get it to, there you go. So you can see I got about 15 volts going into it, which is, I think the inverter will cut out at about 16 volts. And since I have a diode in line up here, there is going to be a little bit of voltage loss going into the inverter. We can power up our inverter here. This button is a little finicky. The inverter's about 12 years old. All right. You see we have a little bit of a voltage loss there, 14.7 versus 15.08, but that is expected. And we'll zoom around here. What we'll do is we'll take this light here that we're using to light the studio. And by studio, I mean basement. I can grab this light over here. Turn that on. Now, if this system draws over 60 watts, which I doubt it's barely, yeah, it's pulling 35 watts right now. This does draw over 60 watts. There's a fan that will kick on inside this inverter. And the fan intakes back here and blows out here. So if I want to add a little extra cooling to that, what I'm going to do is I'm going to take another piece of this nice board that I had. I think it's like a backing board to a bookcase or something. But we can custom cut it and glue it in there so it sits like that. And what that's going to do is it's going to take the air coming through the inverter and pass it over this and provide a little bit of cooling across the heat sinks. But this whole setup right here will run these lights on one of the two battery packs in there for hours. I think you could probably get, I would say around, I don't know, 6 to 8 hours per battery pack. And right now I'm trying to set up a solar charger for it. The only charger that I have is the standard e-bike battery charger. But I could just use the inverter, power the inverter off of something, or plug this directly into the wall. But either way, I have a setup that I can use to charge my e-bike batteries wherever I go, have power wherever I go. So if I want to go into town and do like a video shoot in the evening and I need some lights or something, I got this whole setup. It's under 10 pounds and it's ready to go. But anyway, I just wanted to show this off. I thought you guys would find this really interesting. And in the next video with this, I'm going to do some testing and we're gonna see how far we can stretch this battery pack until it runs out of charge. But luckily we have 2 batteries in here, so we can figure that out twice. Anyway, that's all I have for you today. Until next time, build stuff, have fun, and stay safe.